an antiderivative of a function so if f so a function f of x in capital font is an antiderivative of a function f of x So it's saying that a function f of x is an antiderivative of f of x on an interval I if the derivative of this capital F of x function equals to f of x. So note that this is capital, the derivative is capital F, the function is small f. So if this condition is satisfied, then capital F of x is the antiderivative of the function f of x. So the reverse process of determining or computing capital F of x from f of x
and so we
So the reverse process of finding the antiderivative of a function is what we call integration. And then this antiderivative f of x is not unique. So we can state that one in this theorem. If capital F of x is an antiderivative of the function f of x on an interval I, then the most general so this we call the constant of integration. So there are two main classes of integrals. We have what we call the definite integral and indefinite integral. So the notation so this notation means that if I differentiate capital F of X, I get this function F of X. Then we usually say that F of X plus C is the general antiderivative or the indefinite integral of the function F of X. So we are saying that if I write this sign, and then I have my F of X function, the X, this is called indefinite integral. Then here, this is what we call integration sign. Then this function F of X is called the integrand. Then this X is called variable of integration. So that's what we have. So another class of integrals are what we call the definite integral. So the definite integral is integral from A to B which is read as the integral from A to B of f of x dx. So this is how we read this statement. Then when you write this statement, this b is called upper limit of integration. A is called lower limit of integration. As usual, f of x is the integrand. X is a variable of integration. So let's go to the laboratory and do some experiment. And our experiments in math are always done on the board. So activity. So recall, before we recall, note that the statement simply means find the statement evaluate simply means find a function whose derivative is f of x. So when you say an integral of the evaluate integral of the integral of f of x dx, it simply means can you get a function whose derivative is f of x? So let's demonstrate in an example to see what really this means. So for example, to evaluate integral of x squared dx means find a function whose derivative is x squared. This is the same thing as saying find y such that dy dx will be given by x squared. So know that if we have if y is given by x cubed over 3 plus any other constant, then dy dx will be given by 3 times a third x raised power 3 minus 1, which is simply x power 2. So then, the integral of x squared dx will be x cubed divided by 3 plus c. So another example for activity number 2, evaluate this integral e raised power x dx. So it means, can you get a function whose derivative is e raised power x? Which function will be that? E power x plus c. So recall that if y is given by e power x, then dy dx is given by e power x. So a function whose derivative is, or the family of functions, all functions whose derivative is e raised power x, will simply be e raised power x plus a constant c. So we know that if y is given by sine x, then dy dx is given by
cos
if
x.
you differentiate sine function, you get
Cos x.
cos x. So this is cos x.
Cos x plus c.
Yeah. Okay. Before that, derivative you don't add c. So therefore, if we are evaluating sine x, then the answer becomes cos x then plus c. Oh, okay, the other way around, not this. So it will be cosine of x sine x plus c. Because remember, without me writing this answer, if I block this, then when I write integral of cos x dx, I mean, can you find a function whose derivative is cos x? And that function is sine x. So in general, the integral of cosine of x is positive sine x. Then all family of such kind of functions will be sine x plus c. If y is cos x, what is dy dx?
Negative sine.
Negative sine x. Then if y is negative cos x, then dy dx will be I have a
Sin
function
x.
sine of x. So the integral of sine of x dx will be which function? A function whose derivative is sine x is
Cos x. Negative cos x.
negative cos x. So this negative cos x plus c. So don't confuse what is happening here. So actually, let's add this to our toolbox. So note in general, the integral of cos x dx is sine of x plus c the integral of sine of x dx is negative cos x plus c and the integral of e raised power x dx will be given by e raised power x plus c. Just to make things clearer before we start deep discussion on integrals, note that when you are integrating a cosine function, you get a positive sine function, which is different from the process of differentiation. When you differentiate a cos function, you get a negative sign. But for integration, integral of cos is positive sign. Then when you integrate a sine function, you get a negative cos function, which is opposite to the process of differentiation, whereby if you are differentiating a sine function, you get a positive cos function. So don't confuse. So what is the integral of 1 over x dx? We want to enrich our toolbox. So in simple terms, I'm asking you, can you tell me a function whose derivative is 1 over x? If you recall what you were doing on differentiation, which function gave us a derivative of 1 over x? Which function gave us a derivative of 1 over x?
ln x.
ln of x. So therefore, the answer here will be ln of x plus c. So when you write ln, so we usually put these two vertical lines to mean absolute, because logarithmic functions are only defined for positive quantities. So sometimes instead of just writing x, we usually put these two vertical lines to make emphasis that ln is only defined for positive numbers. And then number 5, integral of sec squared x dx. It's like I'm asking you, can you give me a function whose derivative is sec squared x? Which function has its derivative as sec squared x?
Tan x.
Tan x. So therefore, this will be tan x plus c. Then the other one, integral of cosec squared x dx. A function whose derivative is cosec squared x. From our other discussion,
Sin x plus c.
so can you just check your toolbox if y is given by cot x, then what is dy dx? If y is cot x, dy dx is? Check your book. So negative cosec squared x. So which means then, if I negate this function, y equals to negative cot x, then dy dx will be?
Cosec squared x.
Cosec squared x.
Positive cosec squared.
So therefore, when we are asked to evaluate the integral of cosec squared x dx, which is the same thing as us finding a function whose derivative is cosec squared x, then that function must be negative cot x. So this is negative cot x plus c. Then next tool to put in a toolbox, integral of sec x tan x dx. So the answer I expect you to give me is simply a function whose derivative is sec x tan x. Which function is that? That has a derivative of sec x tan x. So recall that if y is sec x, what is dy dx? Derivative of sec x?
Sec x tan x.
Sec x tan x. So when we have been asked to find the integral of sec x tan x, then it simply means to find a function whose derivative is this function sec x tan x, and that function is sec x. So always recall remember that integration is the reverse process of differentiation. So when you are doing integration, then it's assumed that you know how to differentiate. The other one, integral of cosec x cot x dx. So also recall, if y is cosec x, then what is dy dx?
Negative.
Negative
Cosec x cot x.
cosec x cot x. So then now, because this function is given as a positive, then when we negate this to say y is negative cosec x, then dy dx becomes positive version of this, okay?
Yeah.
Yeah. So which means now the given integral will have the solution as
Cosec x.
so this will be given by cosec x plus c. So you can continue enriching your toolbox by just remembering the relationship between y function and dy dx. And the problem of evaluating the integral of f of x dx simply means find a function whose dy dx is given by this f of x. It's like simply find a function y whose dy dx is given by this function f of x. So once you know that the interpretation, then it will be very easy actually to extend your toolbox to get integrals of very elementary functions that you have dealt with previously. So properties of integrals before we can start evaluating the integrals themselves. So properties of indefinite integrals. So let k be a real number, f of x and g of x be continuous functions. Then the integral of k times f of x dx is the same thing as k integral of f of x dx. If you have a constant or a real number multiplying a function, then when you're integrating, that product is as good as take the constant outside the integration sign and then get the integral of f of x. The answer you have, you multiply them. So this we may say constant multiple rule. Then the integral of f of x plus g of x dx is the same as the integral of f of x dx plus the integral of g of x dx. That if you are integrating sum of two functions, it's the same thing as sum of the integrals of the two functions. Then 3, integral of f of x minus g of x is the same as integral of f of x dx minus integral of g of x dx. These are pretty easy properties to recall. Then let's also state properties of definite integrals. So the first is what we call order of integration. Which says that if I'm integrating from a to b of f of x dx, then it's the same thing as negative integral from b to a of f of x dx. So that simply means that if you reverse the limits of integration, then the final result will be the negative of the original integral. So when upper limit becomes the lower limit and vice versa, then you negate the value of the integral. Then the property number 2 is what we'll call zero width interval. So zero width interval means that if your lower limit is the same as the upper limit, then the value of integration is 0. So integral from a to a of f of x dx is 0. Next is what we call constant multiple rule of property that states that if I'm integrating from a to b, k f of x dx is the same thing as factoring out k, then integrate a to b of the function f of x with respect to x. Number 4 is what we can call sum and difference property. So this one states that if we are integrating from a to b of f of x plus or minus g of x dx will be the same as integral from a to b of f of x dx plus or minus integral from a to b of g of x dx. Number 9 is what we call additivity rule or property. So if I have integral from a to b of f of x dx, then I add to the integral from b to c of the same function f of x, then this is the same thing as saying I'm simply integrating from a to c of f of x dx. This is what we mean here, that if you have an interval, if this is a, this is b, and then this is c. C is a point between a and c. Then to integrate from point a to point c, from a to c, simply means move from a to b, so which is integration from a to b, then move from b to c. So integration of b to c. Then it will have covered the distance from a to c. So we can be asked to compute the value of some arbitrary functions using these properties we have stated here. So for example, suppose I have integral from -1 to 1 of f of x dx to be 5, then integral from 1 to 4 of f of x dx equals to -2, and we have integral from -1 to 1 of h of x dx being 7. Evaluate. Integral from 4 to 1 of f of x dx. Maybe let me call this a, let me call this one b, let me call this other one c. for illustration purpose. So to integrate from 4 to 1 of f of x, which of these three integrals is going to help us to get the answer? Which integral? B. So what did we say? When we reverse the limits of integration, what happens to the value of the integral? What happens when you reverse the limits of integration?
Negative.
It becomes
You negate.
negative.
Yeah, becomes negative. So this by definition will be negative of integral from 1 to 4 of f of x dx, which will be negative of, the answer for this from the question is -2. So finally the answer will be positive 2. Then we have integral from -1 to 1 to f of x plus 3 h of x dx. So the first thing is to supply integration to each of these two functions. So we'll have integral from -1 to 1 of 2 f of x dx plus integral from -1 to 1 of 3 h of x dx. That's the first thing. Then how can we rewrite the first integral?
I don't care how long it takes. A plus C. It's plus
How can we rewrite the first
C
integral now?
is 5. It's going to 2 into
2
Where?
x dx.
Come again.
2 integration of fx.
We
Yeah, so
factor out the
you
2.
factor out 2. So I'll have 2 integral from -1 to 1 of f of x dx. Then similarly, this will be 3 integral from -1 to 1 h of x dx. Then we know from the question the integral from -1 to 1 of f of x is integral from -1 to 1 of f of x is
5.
5. So we replace this by 5. And then the integral from -1 to 1 of h of x was given by 7. So this will be 10 plus 21, which will give us 31. Then number 3, evaluate integral from -1 to 4 of f of x dx. So it's like we are interested in moving from -1 to +4. But remember, in what we have been given, the integrals we have been given, limits we have -1, we have 1, and now we have 4 here. So we have the integral from -1 to 1 defined by A, and we have the integral from 1 to 4 defined by B. So then to evaluate the integral from -1 to 4 of f of x, we'll have to go in 2 steps. First, we'll have to move from -1 to 1, which will use the first integral, then move from 1 to 4, which will be given by the second integral.
Mm, and
So by that, yes, the final then we add, we'll have moved from -1 to +4. So you say this by definition will be given by integral from -1 to 1 of f of x dx, then plus. Now the upper limit of the first integral becomes the lower limit of the second integral, and then up to 4 of f of x dx. So the first limit was, the first integral was given by 5. Then the second integral was given as -2. So when we add,
-3.
-3, correct.
+3. It's positive.
Should be positive. 5 plus -2 is 3. So that is how we can use the properties of integrals to evaluate some given integral values. So methods, some call techniques. Some may even call them rules of integration. So the first one is what we call the power rule. The second one is what we call integration by substitution. Then number 3 is what we call integration by parts. Number 4 is what we call tabular integration, which is just another special way of integration by parts. Number 5 is what we call partial fraction decomposition method. There's also what we call trigonometric substitution. Then we have numerical integration. Under numerical integration, we have what we call trapezoidal rule, which you did in high school. We have Simpson's rule. And also have Simpson's 3/8 rule. So these are the main rules or techniques of integration, which will be thoroughly covered in Calculus 2 and further applications of differentiation. But what you are expected to know in Calculus 1 are only these first two. And once you know how to use power rule and integration by substitution, and you know how to find area under the curve, that will be enough for you in Calculus 1. The rest of the integration methods will be covered in Calculus 2. So power rule is what you used in high school. So power rule says that to integrate a function integral of x power n dx is x power n plus 1 over n plus 1 plus c, where n should never be minus 1. So when n is minus 1, then integral of x power minus 1 dx, which is the same as integral of 1 over x dx, becomes ln of x plus c. So for example, evaluate integral of x power 5 dx. So here, we'll simply have x power 5 plus 1 over 5 plus 1, then plus c.
So
This will reduce to
x power 6 over 6 plus c.
x power 6 over 6 plus c. Correct. Then example 2, integrate x squared minus 2x plus 5 dx. So here we'll have x power 2 plus 1 over 2 plus 1 minus 2x power 1 plus 1 over 1 plus 1. So remember, when I don't have an x, it's like x power 0. So I'll have 5 x power 0 plus 1 over 0 plus 1, then plus c. So this will give us x power 3 over 3 minus 2x power 2 over 2 plus 5x power 1 over 1 plus c, which is just x power 3 over 3 minus x squared, then plus 5x plus c.
Okay, right.
Then I want you to try this. Integral of 3x power 4 minus 5x power 2 over 3 plus x raised power minus 3 dx. So try to compute the integral of that given function. So when you get the answer, you unmute and say it. So the first one will be
3x power 5 over
X power 5 over 5.
so you have 3 over 5 x power 5. Then
minus 5x 5 over 3 over 5 over
minus
5x
5x 5 over 3 over 5 over 3.
5 over 3.
so can you simplify that fraction and tell me the simplify the value?
Come on, man. Times 3 over 5.
So when you add 1 to 2 over 3, you get
5 over 3.
5 over 3. So what is 5 over 5 over 3?
3.
3. So I'll have 3 x power 5 over 3. Then
Minus x
minus x,
power negative 2 over 2.
correct. And then plus c.
Plus
Don't
c.
forget to add constant of integration c.
Oh, it was negative.
So the last method, substitution method. So you can do as many problems as you like on the power rule. It's exactly the same thing we are doing in high school. So substitution method, and the last method for this course, for which is required for calculus 1, substitution. So if we have u is a function of x, whose range is an interval I, and f is continuous, on this same interval I, then the integral of f of g of x times g prime of x dx is the same as the integral of f of u du. So you shouldn't be scared by the statement of the process. Things will make more sense in the examples.
Amen.
So for example, evaluate the following integrals. So the first one is integral of x cubed plus x power 5 into 3x squared plus 1 dx. So usually what happens, you have to study your integrand and fix part of the integrand or the whole integrand to a variable u, such that when you differentiate that u, then it can give you an expression that will convert the whole integral in terms of this new variable u, such that the new integrand in terms of u is easier to evaluate using the standard integrals of the standard method, what we have done previously, the power rule. So this is what we'll do in such a case. So I'll say, let u to be given by x cubed plus x. So then now this implies we differentiate both sides. So the left-hand side will give us du. The right-hand side will be differentiating with respect to x. So derivative of x power 3 will give us 3x squared. Derivative of x will give us 1. And then write dx. Is actually the same thing as saying du dx. When you differentiate this one, you get 3x squared by dx. So this is what I'll have. Now, you see where there's 3x squared plus 1 dx, you can substitute by the du expression. So which means then that this integral x power 3 plus x power 5 into 3x squared plus 1 dx can be written as integral, this bracket we have fixed it to be u, so it'll be u power 5. And from here, you can clearly see that all this expression is equivalent to du. So then you replace all this by du. So by doing that, we have successfully transformed the original integral in terms of this new variable u. And now what we have is very easy to integrate using power rule, which will be u power 5 plus 1 over 5 plus 1, then plus c. This will be u power 6 over 6, then plus c. But recall, u is our own variable, was not in the question. So the final answer, you replace back the expression of u in terms of x. So therefore, this will be x power 3 plus x raised power 6 divided by 6, then plus c. So that will be the value of that integral. So you get your 1 or 2 marks of that integration process. Then if that didn't make sense, integral of square root of 2x plus 1 dx. Who can tell us the starting point? What should we do? What should we do in this case?
X plus 1 raised to
Correct. So we can write this one as integral of 2x plus 1 raised power half, then dx. So what will be our u?
X plus
2x plus 1, correct. So which means that the u dx will be the u dx 2,
Two.
correct.
huh? Wait.
So which is the same language as saying the u alone is
How is that 2?
If you make du the subject,
2 dx.
2 dx. So multiply both sides by dx. Which is the same language as saying dx alone is?
du over 2.
Du over 2, correct. Du over 2. So therefore now the integral of square root of 2x plus 1 dx, which is the same as the integral of 2x plus 1 power half dx, will be the integral. So all these brackets you have fixed to be u power half. Then where there's dx, we replace by du over 2. Then we factor out this half. So we'll have a half integral of u power a half, then du. So you see we have successfully transformed the variable, the integrand or the integral in terms of the new variable u. And now we can easily use power rule to get the answer. So this will be a half times u power half plus 1 over half plus 1, then plus 6. So 1 plus a half is
3 over 2.
3 over 2. So what is the reciprocal of 3 over 2? This is
2 over 3.
Over
2
3.
over 3. Then when you multiply by a half,
Over 6.
so we'll have a half 2 over 3 to give us
1 over 3.
1 over 3. So I'll have 1 over 3 u raised to power 3 over 2 plus c. But please don't leave your answer in terms of u because u was never in the question. It's just our own creation to simplify the problem. So therefore, we'll have a third into 2x plus 1 power 3 over 2, then plus c.
2x. Plus c. Yeah. That makes sense. Kidogo. I know, sec.
So the next one is the integral of sec squared of 5x plus 1 times 5 dx. So the key thing to do is to know what to fix as u. So once you know what to fix as u, then it reduces the integral into a standard integral you can evaluate without struggle. So what will be the best choice for u in this case?
5x plus 1.
5x plus 1, correct. So this means du dx is 5, or in the same language as saying that du alone is
5 dx.
5 dx, correct. And we can clearly see a 5 dx in the integrand. So we don't interfere with this. We can as well make the dx the subject, but because we can clearly see that all this expression is what we have here, then we just replace this one by du and reduce the integral in terms of the variable u. So integral of sec squared of 5x plus 1 times 5 dx will now be the integral of sec squared. So this is u. Instead of having 5 dx, we replace by du. So we'll have this one as du. So what is the value of the integral of sec squared u du?
But when you analyze your parts, give you 2 piece, give you 2 piece, 2 piece.
So which function has a derivative as sec squared function?
Tan x.
Tan x. So, but now remember here the variable is u. So the integral of sec squared u du is just turn u, then plus c. But you don't leave your answer in terms of u, you replace with its expression in terms of x.
5x plus 1. Oh.
Yeah. Can you be trusted with this? Integral of cos 7 theta plus 3 d theta and integral of x squared e power x power 3 dx.
No.
Can you try to work out 4 and 5?
Girl, just do them. I feel like E will be a bit hard for me, but okay. Okay. Take a challenge. We take the challenge, bro. Because I fucking it's the fact that it's theta. So my brain has already turned off. So let's try it. You
June, mute mic.
So just to save on time, maybe we can do it together. So what would be for number 4? What would be the best choice for you?
Seven theta plus
7 theta plus 3. So which implies the u d theta would be
7.
7. Or the u alone will be
7 d theta.
7 d theta.
7
Which
d theta.
means the theta alone will be
d over 7.
d over 7.
D
correct.
over 7.
Yeah, so where there's the theta, you replace by d over 7 to change the variable in terms of u. So this will give us this integral of cos 7 theta plus 3 d theta will be integral of cosine of where there's this bracket we put u, where there's the theta we put du over
d over
7.
7.
Yeah. So this 1 over 7 can be factored outside the integration sign. So you write 1 over 7 integral of cos u du. So the integral of cosine function is always
Negative sign.
Negative sign.
positive sign.
Inside.
So
Positive.
when you are integrating cosine, the answer is positive sign. Don't confuse with when you are differentiating cosine. So this will be 1 over 7 sine u plus c. So you replace with the actual value of u, it will be 1 over 7 sine of 7 theta plus 3, then plus c. So recall that integral of cos function is sine function.
Sine function.
Integral of sine function is what gives you the negative cos. So they are opposites the way you are dealing with integration and differentiation.
Oh, because when we differentiate sine, we get cos.
Yeah. So because remember, once you write the integral of cos u du, it's the same thing as asking you, can you find the function whose derivative is this cos u? And that function is sine u. Yeah.
Yeah.
Then this other one, what will be the best choice of u? And you have to be, okay, this is actually the, you should actually be very smart when you are using substitution method. What you fix to be u, remember that you need to differentiate it. When you say let this part be u, you'll have to differentiate that u. And so ensure that by the process, by the essence of fixing one part to be u, is to make the integral much simpler to evaluate than its natural form. So it'd be very useless or be very wrong to fix one part of the integrand to be u that creates another integral which is very complicated to integrate. So you'll actually be missing out the concept. the concept is to fix one part of the integral so that we transform the integral into a form which we can easily integrate using either power rule or those standard integrals that we're putting in the toolbox. So as you do that one, always take that into consideration. And if there are two parts of the integrand where it's like you have a liberty to fix one to be u or the other, then note that the best choice for you will be that function, which when you differentiate will give you something which looks the same as the other part so that they can cancel out in the transformation. So that's actually the trick. You fix part which can cancel the other part when you are doing the transformation to make integrand much simpler to evaluate than its natural form. So here we can see an x squared or an x power 3. So which of these two is the best choice for you? Not all of them will work. One of them will work.
X power 3.
X power 3, because we know that when we differentiate x power 3, we are going to have an x squared in the answer, which when we transform, then it will cancel this other x squared. So therefore, here we let x power 3 to be u. So which means du will be du dx
3x power 2.
3x power 2, correct. Or in the same language of saying du alone is
3x squared dx.
3x squared dx. Which means dx alone, when you make it the subject, will be
du over 3x squared.
Yeah, du over 3x squared. Then now you replace back. So here we'll have integral of x squared e power x power 3 dx will be the integral of x squared e power this x power 3 is u times where there's dx you put du over 3x squared. So x squared and x squared cancels out. Then you see we'll have successfully changed everything in terms of u. Then factor out their third. So this will be a third integral of e power u du, which is actually a standard integral. So the integral of e power u du is a function whose derivative is e power u.
U plus C.
This will be a third. Which function, when you differentiate, you get e power u.
U plus C.
So this is the same e power u plus c. But you recall that u was x power 3, so the answer will be a third e raised power x power 3 plus c. Now, if you get this one, I can stop. That was number 5. So if you get 6 and 7, then I'll stop. So 6 is the integral of x squared plus 2x over x cubed plus 3x squared plus 12 power 6 dx. And then number 7 is the integral of x square root of 5x plus 1 dx. If you get those two problems, I can stop. Are you going to be starting at 6 or 5:30?
Huh?
Okay, so evaluate this. Tell me the answer. If you get it right, I'll stop. So maybe just to save on time, we can do it together maybe. So number 6, what will be the best choice of u? Numerator or denominator?
X cubic plus 3x squared
Yeah.
plus.
Yeah, this bracket in the denominator, correct? X cubed plus 3x squared plus 12. So du dx will be
3x squared
3x
plus
squared
6x.
plus 6x.
3x squared plus 6x.
6x.
So which means then the du alone will be
3x squared plus 6x into brackets dx.
correct. Or if you make dx the subject,
Divide both sides by the numbers in the bracket.
yeah, so du over the bracket. And this can be written as du over 3 is common, so I'll have 3 into x squared plus 2x. So then now let's change the original integral into this new variable u. So the integral of x squared plus 2x divided by x cubed plus 3x squared plus 12 power 6 dx will be given by integral x squared plus 2x in brackets divided by u power 6 times dx alone. We have found the answer to be du over 3 into x squared plus 2x. So we clearly see that this bracket and this bracket cancels out, so that we'll have a third integral of 1 over u power 6 du, and you can rewrite this one as a third integral of u power minus 6 du. So what will be the final? We'll have u power minus 6 plus 1 minus 6 plus 1, then plus c. So on simplification, we'll have which fraction times u power minus 5? So which fraction power multiplied by u power minus 5? I know you are already tired, so this one, then I finish. When I finish, then I will stop. So I'm not continuing after working out the solution to the two problems. So this signifies to a third times
U
1
power
over
5
minus 5.
over.
So negative 1 over
1 over 15.
15, correct. Then u power minus 5 plus c. So which will give us minus 1 over 15 into x cubed plus 3x squared plus 12 raised power minus 5 plus c. Then you get your 1 or 2 marks. Then finally, the last one, we have integral of x square root of 5x plus 1 dx. So the most natural thing will be to write this as a power. So this will be x into 5x plus 1 power half. So by doing so, what would be the best choice for u?
Five x plus 1.
5x plus 1. So u 5x plus 1. So which means du dx will be
5.
5. So which means then du alone will be 5 dx, which means dx alone will be du over 5. So note that when we replace where there's dx by du, we will not remove this x which is outside the square root sign. But the beauty is that after fixing u to 5x plus 1, we can actually solve for x in terms of u. So what is the value of x in terms of u from this? If you convert or
U
you
minus
change
1 over 5.
u over 5 minus
Minus 1.
okay, maybe this from 3 work. U equals to 5x plus 1. So take 1 to the opposite side, we'll have 5x equals to u minus 1. Then divide through by 5 by 5. So this will be u over 5 minus 1 over 5. So therefore, to rewrite this integral, we'll have the integral of u over 5 minus 1 over 5 times this square root of 5x plus 1 will be u power a half then times the x alone in this integral will be du over 5. From that point, can you be trusted to finish it up?
We finish it.
Okay, so let's just finish. Why not? So what is u power? So remember, u is the same as u power 1. So u power half times u a half plus 1 will give us the power of here is 1. So what is 1 plus a half?
3
3
over
over 2. Then this will be minus 1 over 5 u power a half. Then multiply by the u over 5. So this 5, this 2 will get integral of u power 3 over 2 over 25 minus u power half over 25 du. Then you can factor out 1 over 25. So u power 3 over 2 minus u power half, then du. So then that this just apply the usual power rule. So I'll have u power 3 over 2 plus 1, 3 over 2 plus 1, then minus u over u raised power a half plus 1 over a half plus 1, then plus 3. So 1 plus 3 over 2 is 5 over 2, I guess. What is the reciprocal of 5 over 2?
2 over 5.
2 over 5. We have 1 over 25 into 2 over 5 u power 5 over 2. And then reciprocal of 3 over 2.
2 over 3.
2 over 3. And then u power 3 over 2. Then plus c. So 1 over 25 times 2 over 5. Will be 2 over 25 by 5.
25.
125.
2 over
Are you ready?
25.
Then u power 5 over 2. Then minus 3 over 2 times 1 over 25. The 2 over
75.
75.
75.
Then u power 3 over 2 plus c. So then the final thing is just now to replace what we fixed to be u. So this would be 2 over 125 into 5x plus 1 power 5 over 2 minus 2 over 75, 5x plus 1 raised power 3 over 2, then plus c. That will be the final answer. Because of time, I'll not continue. The remaining bit about area and fundamental theorem of calculus, I'll do it and share. So that will be enough to make you be comfortable in the next exercise next week. So we'll meet on the exam day. Do your best. If you have a problem in between, feel free to ask. We shall support. Have a good weekend.